Let us look at probability density functions, and the best way to understand probability densities is through examples. Let us look at the example of soil samples and then measuring some concentration of some chemicals in the soil. So here, for example, I show you a whole bunch of soil samples which have been collected. You put a probe of this into a test tube and you dissolve it with some water, and then you get a whole bunch of test tubes which all have different concentrations of a chemical. Maybe we are interested in the nitrogen contents. Okay, so we measure all these test tubes and we might find 200 milligrams in one and 190 milligrams in the other one, and maybe 220 in the next one, and so on. They will all be a little bit different, but also maybe a little bit similar. So what we get in the end is a probability distribution. We get a probability distribution over the different content of nitrogen in these samples. And this is what we call a probability density function. So just for the sake of example, let us assume the nitrogen concentration in soil samples has been measured, and they found a probability density function f of x given by this, 192x times 1/2 minus x squared. And this in the interval from 0 to 0.5. And the units are gram per kilogram, so gram of nitrogen per kilogram of soil. If you plot it, then this is this function. So you see, it is very likely to find nitrogen content in the area around 0.2 or a little bit less than 0.2, because this is where the function has a maximum. And it is much less likely to find something near 0.5 or near 0.0. So let's first check the two conditions to be a probability density function. One was that f has to be larger or equal to 0, and the other one that it integrates to 1. So let's check this. First of all, f of x larger or equal to 0. Yeah, looking at the formula, so this is check. A little bit more work is the condition that integral from minus infinity to plus infinity of f of x dx is equal to 1. Okay, let us check this. Now, this is a general formula, minus to plus infinity, but our nitrogen concentration will never be a negative number. And also from our definition, we see it's only defined really between 0 and 0.5. So in our case, we compute the integral from 0 to 1/2 of this function, 192x 1/2 minus x square dx. Okay? We have to integrate this. I take the 192 out to the front from 0 to 1/2, and then I do the square first of all. So then I get a quarter minus x plus x squared dx. I multiply the x, 192, integral 0 to 1/2. Then I get x quarters minus x squared plus x cubed dx. Integrating polynomials is fun, so 192, and then this integrates to x squared over 8 minus x cubed over 3 plus x to the 4 over 4, and then all this evaluated from 0 to 1/2. So subbing in the 1/2, I keep the 192 in the front. Then we have a quarter divided by 8. This is 32, so 1 over 32 minus, and then we have an 8th divided by 3 is 1 over 24, and then plus we have 1 over 16, and then 4 times this is 1 over 64, like this. And so we can find a common denominator, which turns out to be 192. And then the 32 is 6 times, and the 24 is 8 times, and the 64 is 3 times 192. And this turns out to be, ta-da-ta-da-ta-da, 1. And this is what we wanted. So it is really a proper probability density function. Now, what does it mean? So let's use it to determine the probability that a randomly selected soil sample will have a nitrogen concentration between 225 and 240 milligram per kilogram Remember, our units were gram per kilogram, so we have to transfer this into 0.225 gram per kilogram, and the other one is 0.24 gram per kilogram. So the probability to be in this interval can be computed by integrating the probability density function. The probability that 0.225 is less or equal x less or equal 0.240. So the probability that our measurement is in this interval is the integral 0.225 to 0.240 of our function f of x dx. We have to integrate this function again, so I sub in the 192x times a half minus x squared, and I do the same integration I just did. I follow it to the step where I found the antiderivative. This was x squared over 8 minus x cubed third plus x to the 4 quarters, but now between 0.225 and 0.240. Okay, so now we need the calculator, the power of the calculator. So what we get is 0.0479. All right, so we found a number. What does this number mean? This number is the probability to find a nitrogen concentration between 225 and 240 milligram per kilogram. There's another way you can see this. If you multiply this number by 100, you get a percentage. And so then 4.79 is the percentage of soil samples which have a nitrogen concentration in this interval, 224 and 240 milligram per kilogram. So let us illustrate the previous calculation in a graph. Here is the graph of f again. And so what was the little interval? This was 0.225, maybe here, and then this 0.24 is maybe there. We integrated the function, so we computed this area here, 0.0479. And this is the area under the curve between the points 0.225 and 0.240. What is this? Let's check this out. What is going on here?